Hi and welcome to this video on 3D vectors. It's just the single video that we're going to have on 3D vectors because to be honest, anything you can do with 2D vectors you can do with 3D vectors. There's a couple of little bits and pieces to talk about, but essentially if you've done all your work on 2D vectors then you know what you're doing. It's just how we adapt it for 3D vectors. So let's just kind of quickly blast through all these bits and pieces. So coordinates in three dimensions, 3D vectors, solving geometric problems and also problems in mechanics. So here we go. So let's find the distance from O to P, given that P is 2 minus 1, 3. So there we've got our 3D axes, and there's our point P. Now, what I'm going to do is just do a little bit more thinking about how we're going to find that distance OP, that thing there. And to do that, OP is the hypotenuse of a right angled triangle, which has got a height which is 3. And the base is that grey line there. So what we're going to need to do is work out the length of the grey dashed line there. So what I'm going to do is just a little bit of extra scribbling. I'm going to call this value here, let's call it M, and I'm going to call that point there N. So if I want to find the distance to the grey value there, the grey line, I'm going to go OM squared is going to be ON squared plus MN squared. So that's going to be 2 squared plus minus 1 squared, which I'm just going to write that as 2 squared plus 1 squared. There we go. Now, what we've got is OP, the distance we want. So if we say OP squared is going to be OM squared plus MP squared. And the OM squared is this bit here. So that's just going to be the 2 squared plus 1 squared plus MP squared, which is just MP is our distance 3. So essentially what we've got therefore is, I'll come over here, OP is going to be the square root of 2 squared plus 1 squared plus 3 squared. Essentially what we're saying is to find the distance OP you can just use Pythagoras with the 3 values exactly as it is. So that keeps life nice and happy. So let's just get rid of that and just say we've got OP therefore is 2 squared plus the minus 1 squared, so I've underlined that, that's our grey bit, plus the 3 squared, and so there you go, square root of 14. So Pythagoras theorem works in 3 dimensions in exactly the same way as it does in 2 dimensions. Nice and simple. So if we had a coordinate geometry question, we had the distance between 2 points. I've put up an extra point on my diagram there. So let's have a look. We need the distance PQ, which is the blue line. So let's just put in all the relevant triangles. I've just put that there just to kind of help you see what's going on. But essentially it's just going to be exactly the same as what we do in 2 dimensions. So we've got the distance between the x coordinates, so that's 2 minus 3, the distance between the y coordinates, minus 1 minus 3, and the difference between the z coordinates, which is 3 minus 0. Do all of that, do the squaring, you end up with square root 26, and there you go. So there's not a major difference between 2D and 3D in terms of how we find distance between points. So let's have a quick look at a coordinate geometry question in 3 dimensions. So we've got points A and B. So we've got 2 minus 1, 5, and B is at 5k minus 3k. And we're told the distance between A and B is root 139. Find values of k. Standard stuff in 2 dimensions, exactly the same in 3 dimensions. So let's go root 139 is the square root of the difference between the coordinates. We can get rid of the square root and do some tidying up and multiplying out of our brackets. So 5 minus 2, that's the 9. This bit here, that's the k plus 1 all squared. And clearly this bit here is minus 3k minus 5 all squared. It turns into a quadratic. Solve the quadratic using whatever method you want, and you end up with, there you go, there's our 2 values for k. Right. That's the basics of coordinates. We did prefix this video by saying we're looking at vectors, so let's now have a look at 3D vectors. Previously you'll have seen 2D vectors, you'll have seen the unit vectors I and j, which were 1, 0 and 0, 1. Now we've got the equivalent in 3 dimensions, so I is 1, 0, 0, j, 0, 1, 0, k, 0, 0, 1. And for any 3D vector we can write it using I, j and k, or just write it as a column vector like that. Again, magnitude of a vector is just the square of all the values, same as with 2D. The extra little bit that you're going to have to deal with is potentially a question about the angle between the vector and any of the coordinate axes. So this is an extra fact that you're going to need with 3D vectors. Let's just have a look at what's going on. We need the angle between A and the angle between that and the coordinate axis. So that's the angle between that and the x-axis, let's say, for example. So we'll call that theta x, and let's just have a look at what happens if I can draw in what theta x actually looks like. And so what you've got there is a right angle triangle that's kind of tilted over. We know that this value here is x. Here we've got the magnitude of A. So if I'm going to do cos, which is going to be adjacent over hypotenuse, I end up with that. The equivalence between the y-axis, let's just draw that one out. There it is. Same principles. So hopefully we can see that's going to be cos theta y is going to be y over mod A. And finally, cos theta z, so the angle between our vector and the z-axis is going to be cos theta z equals z over mod A. So that's just a little extra twiddle that you need to know about. I'm not going to do a whole lot more with that. We're just going to move swiftly on. So we've got a geometric problem. So we've got a triangle ABC in terms of 3 dimensions. So let's have a look at it. Let's draw it out. So we've got there's AB and there's AC. And we need to find the side of angle BAC. So let's just put in the extra side there. And that's the angle we're looking for. So hopefully you can see that this is going to become a cosine rule question. So we're going to need a couple of things. We're going to need to work out the vector BC. And then once we've got that, we're going to need the length of all 3 sides, which is the magnitude of each vector. So off we go, vector BC. So to get from B to C, we're going to have to go B to A to C. So there's our standard minus A plus C type of setup. So here it is. And so there is our vector BC, minus 1, 7, minus 7. We now need the magnitude of all 3 vectors, which we can do using Pythagoras. So AB, there it is, square root of 2 squared plus 4 squared plus 5 squared. AC is root 14. I'm not going to include all the calculation again. You can see what's going on. BC is root 99. And so therefore, if I want to find the size of that angle, I'm going to have to do a bit of cosine rule, as we said before. BC squared equals AB squared plus AC squared minus 2AB times AC cos A. And so that's the thing that we're aiming for. So let's plug in all the things that we know. Making sure, of course, that BC is the opposite side. So that's the one that needs to appear on the left-hand side of our cosine rule. These are all squares. We've got these in terms of square roots. So I can just write it like that. The only bit being these 2 bits here, that's where I still need the roots. Bit of rearranging and tidying up and inverse the cos. And we end up with our angle A is 122.7 degrees. And there you go. So that's geometric problem solving with vectors sorted in 3 dimensions. Let's have a look at an application of mechanics question. And again, they don't assume that you've got knowledge of mechanics on a pure paper, so it might be they'll give you a little bit more information to work with in the actual question. But I'm assuming you do know what you're doing with mechanics for this particular one. So clearly we're going to be using F equals ma. So we're going to need to know the force. So we're going to need the magnitude of the force, the resultant. So let's start there. There we go. There's our resultant force, which is going to be 403 newtons. That's that bit done. We need the magnitude of that. So let's do magnitude using Pythagoras. Turns out to be 5 newtons. We've now got F equals ma, and chances are, let's say, if they wanted you to use that on a pure paper, it would be there in the question for you. So F is 5 equals 2 times A, and there you go. There's our show that A equals 2.5, and there you go. There it is, done and all sorted.